Hey guys, today we are going to be talking about verifying inverse functions, okay? So I'm going to verify that two functions are inverse. And the way you do that is first you would see if f of g of x is equal to x, and then is g of f of x also equal to x? And if they are both equal to x, then you would say that they are inverse functions, okay? So the two functions we're going to be dealing with, I'll say f of x is equal to 1 over 3x plus 5/3. And I'll say g of x is equal to 3x minus 5. All right. So we're going to verify that these two are inverses. Let's see if that works. So f of x. So I need to do f of g of x equals x first. Let's do that first. So I will do f of g of x. Well, that's 3x minus 5. All right. And I'm going to plug that in here into my 1/3 x plus 5/3. So that's 1/3 times 3x minus 5 plus 5/3. Well, let's simplify that. That'll be 3x minus 5 over 3 plus 5/3. Notice that they both have a 3 on the bottom. The denominator is 3, so they have common denominators. So I can combine them into one fraction. So they will be 3x minus 5 plus 5 over 3. All right. Notice that there's a negative 5 and a positive 5. So those are going to cancel each other out. And I'm left with 3x over 3. But 3 divided by 3 is 1. So that equals x. So that one worked. Check. Now let's do g of f of x. So I have g of, what is f of x? F of x is 1 over 3x plus 5/3. So now I'm going to plug that into my g of x function. So g, actually here, let's, so this is equal to 3 times 1 over 3x plus 5/3 minus 5. We replaced this x with this. Okay. So now if I multiply this 3 into the parentheses, that 3 eliminates both denominators, cancels them out, because multiplying by a divided 3 basically leaves me with 1x plus 5 minus 5. Well, plus 5 minus 5, that equals 0. So that cancels, and I'm left with 1x. And 1x is equal to x. So g of f of x equals x. Check. f of g of x equals x, check. So did we verify that these functions are inverse? Yes.